So we have our fourth problem here to our grade 8 students and to our viewers. So we have here Jesse built a hexagonal pod that houses his most expensive sweets. The said pod is encased in a cylinder with water in it. So the pod is a regular hexagon with an edge length of 2 inches. The cylinder's radius is 2 inches and its height is 4 inches. What is the volume of the water inside of the cylinder, rounded to the nearest cubic inch? So how can we solve for this problem, grade 8 students? So for this one, we know that we have here a hexagon on top. And what other facts or what other properties do we know about the hexagon? It's a regular hexagon. Okay, for this one, a hexagonal pod that houses his sweets, and it's a regular hexagon. And if we have a regular polygon, it always has equilateral triangles. So therefore, if this is an equilateral triangle, it's also equiangular. So therefore, if it's an equiangular triangle, we know the formula for finding the area of an equiangular triangle just by using its side measurement. So that's gonna be equal to s squared all over 4 multiplied to the square root of 3. Identify the formula for finding the area of an equilateral triangle given its side measurement. We can now find the area of one of the triangles inside of this hexagon. So therefore, that's gonna give us 2 squared all over 4 multiplied by the square root of 3. This cancels out. So therefore, one equilateral triangle is gonna be equal to the square root of 3. And since there are 6 triangles there, we can multiply it by 6 because that's 1, 2, 3, 4, 5, 6. There's 6 equilateral triangles in the hexagon. So therefore, the total area of the hexagon is gonna be equal to 6 square root of 3. So now that we know the area of the hexagon, we can also find its volume. So how do we find the volume? We just multiply the 6 square root of 3 that we have here with 4. That should give us the volume of the hexagonal pod that's inside of the cylindrical container. So therefore, the volume of the hexagonal pod is just gonna be the area, the base area of the hexagon multiplied by the height. Okay, so that's the height. So therefore, that's gonna give us 6 square root of 3 times 4. So therefore, the volume of the hexagonal pod is gonna be 24 square root of 3 cubic inches. So that's for the hexagonal pod. We still haven't yet solved for the area of the cylinder. That's gonna be very easy. The formula for finding the area of a cylinder, that's just the base, which is pi r squared multiplied by the height. And triangle, so therefore this must be also 2. So that we have here 2 squared times the height, which is just equal to 4. And therefore the volume of the cylinder is just gonna be 16 pi cubic inches for this one. And now that we solve for the volume of the cylinder and the volume of the hexagonal pod, we can subtract these two in order to get the water, because that's the question here. What's the volume of the water here that's outside of the hexagonal pod but inside of the cylindrical container? So therefore, to get the volume of the water, that's just gonna be the volume of the cylinder. Okay, so that's gonna be the volume. Okay, so that's just gonna be the volume of the cylinder. Okay, minus the volume of the hexagonal of our hexagonal pod. So there you go. So therefore, what's the volume of the cylinder? So that's equal to 16 pi cubic inches. And what's the formula for the what's the value? What's the value for the hexagonal pod? So that's 24 multiplied by square root of 3 cubic inches. So this is gonna give us 16. Okay, 6. So that's gonna give us 16 pi minus 24 square root of 3. So that should give us 8.70. So there you go. So therefore, the volume of the water is just equal to 8.70 square cubic inches. Okay, but it says here we need to round it we need to round the volume to the nearest cubic inch. So how are we going to round the answer to the nearest cubic inch if we have your 8.70 cubic inches as the volume? Well, we just, okay, round it up. So that's going to give us 9 cubic inches. So therefore, the volume of the water in the cylindrical tank given these proportions is equal to 9 cubic inches. And that's how we solve the problem.